Okay, since I'm going to show you how to construct the 4 points of concurrency, one circumcenter, incenter, median or centroid, and orthocenter. Okay. Um, you might have already done a couple of these by individual segment, perpendicular bisector, angle bisector already in a prior worksheet. We're now doing it with an entire triangle, which means we're going to do it with all three sides or all three angles. Now, technically, you only have to do it with two, because the two where they intersect, the third one will intersect there as well. So if you end up being very slow at this, you might just do two sides or two angles and find their point of intersection, so you can keep up with the rest of the class on doing the others. Okay, so the circumcenter, when we're done, when we find the point of intersection, it will end up being equidistant from all three vertices. Okay, and we'll see that, and we'll be able to draw a circle around the whole triangle, depending on how accurate we actually found our three perpendicular bisectors. Okay, so I should write down here three perpendicular bisectors. And obviously, to be a perpendicular bisector, you're having to do it of the sides of the three sides of the triangle. Okay, so that's what we're looking to do. And remember, you put your pointer at one vertex, open it up more than halfway. Okay, so that's more than halfway. And then I go ahead and draw a semicircle. Okay, then I go ahead and turn it around, put the pointer on the other end of the segment, and draw the semicircle. So I find where the 2 points intersect, and I go ahead and take my straight edge, or protractor, or ruler, and connect those 2 points of intersection. Okay, so you can see that got a little bit off. That's about as close as I can get it right there. Okay, so that's one side. Now I'm just repeating those same steps. So from this side here, put it here. If I want to shrink that in some, I can, because that's now more than halfway. See, that's more than halfway right there. Okay, again, draw a semicircle. Okay, then turn it around, put the pointer on this end of this segment, and draw this semicircle to find the point of intersection. Okay, so now I'm just moving it off right here. Take my straight edge and go through the points of intersection until they intersect. Okay, so I need a second to move this a little bit so it goes right in there. Okay, so now technically I'm done enough. So I found this point of intersection. Let's make it blue right there. Okay, that means when I do the third one, it should intersect right there on the third side as well. Okay, so if I go ahead and put the pointer there, this is the third side, that's more than halfway. Draw my semicircle. Okay, turn it around, put the pointer on the other end, draw the semicircle. Oops, okay, right back there where it was. Draw the semicircle. Okay, so notice I have 3 pairs of semicircles. That's what you should have if you're doing all 3. Then I go ahead and again connect them right on through there. Okay, and if this is right, that's right there, and that would go right through there. Okay, and so we see that they intersect same spot or super close right there where that blue is. Okay, so now to see that I'm right, if I go ahead and put that pointer on that intersection point, move my pencil to one of the vertices. Okay, that's just about there. Maybe I'll get a little better. That's about as good as I can get it right there. So now, if I draw a circle through that, remember this is called the circumcenter right here, that point of concurrency, that is the circumcenter. Oops, circumcenter. If I did it correctly, I put my pointer there, put a pencil on one of the vertices. Doesn't matter which one. I draw a circle now. Let's see if I can change the color here. I'll go green. Let's see that. Draw a circle now, and it should go through all 3 vertices. Okay, so notice, oops, let's move this off. I'm very close. Okay, that's the top one's a little bit off and the right one's just barely off. So that tells me my circumcenter was almost perfect. Okay, so that's what allows you to create a circumcenter. 3 perpendicular bisectors of each side. Technically, you only need 2. The third one should intersect in the same spot. And what that is showing, that circumcenter, that point of concurrency called the circumcenter, is equidistant from all 3 vertices. Okay, because each one is a radii. So from that circumcenter is equidistant from all 3 vertices. That could be a potential test question. All right, next one. Incenter. The incenter comes from 3 angle bisectors. So we've done an angle bisector before. Now we're going to do 3 of them from each angle. So again, I put my pointer at one of the vertices. Open it up, a certain amount, maybe that amount. There's no set amount. And draw an arc. So I get 2 points of intersection, one on each side of the ray or segment here to create that created the angle. Then I go ahead and put the pointer on one of those points of intersection. And I can see that that is more than halfway. It just has to be more than halfway. So it's way more than halfway. So if I wanted to, I can move it in more. That's still more than halfway. Okay. So now I go ahead and draw an arc. I just need on the inside here because it's going to bisect that angle, because the other side I'm going to use is the vertex itself. So now I switch it, put the pointer on the other point of intersection. Okay, go ahead and move it in here like this, and then draw my arc like that. Okay, then I can move this off and take my straight edge or ruler and connect it right on through there. Okay, so it goes through the vertex and that intersection right there. Now I'm just going to repeat those steps with the other angles. Okay, so put the pointer there. Okay, draw an arc like that. There's my 2 points of intersection. Put a pointer on one of them. Notice that's more than halfway, way more than halfway. Okay, so that's fine. I'm going to go ahead and draw an arc on the inside. Oops, didn't draw it. On the inside right there. Okay, then turn it around. Put the pointer on the other end. Okay, get that right in there. And draw my semicircle there. Oops. Okay, now I go ahead, take my straight edge or ruler and go through that point of intersection and through the corner, the vertex itself. Okay, so there would be my incenter. This piece right here, this point right there. That means the third one, that third angle bisector should go right through that as well. So again, if you're slower doing this, you can just do 2 of them and find that point of intersection called the incenter. So that's my incenter right there. Okay, and as you see that, the incenter is equidistant from the sides of the triangle. We'll see that because we'll draw a circle that touches each side of the triangle once if our center is perfect. Okay, so let's just go ahead and finish off the make it a little bit smaller right in there. Okay, draw an arc right there. Okay, put the pointer on one of those intersection points. Draw a semicircle right in here, just a little arc. Turn it around, put the pointer on the other intersection point. Okay, and draw that right there. Okay, then I take my straight edge, go from the vertex through that point. Okay, and it should be right there and right there like that. Okay, And so you can see it goes through that point. So they intersect right there, all three, as they should. I did it right. And I should be able to see that each of those rays I drew, if I put arrows on the ends of them, they'd be rays, otherwise they're segments, bisect each other. It should look halfway in between. So again, now I can go ahead and put a pointer on that point of concurrency, in this case called the in-center, and then go what I think is 90 degrees to one of the sides. Okay, and that looks about 90 degrees. Okay, can I get it to hit? It's gonna be close right there. That's about as close as I can get it. And then go ahead and draw a circle from there, and it should touch each side once. Okay, and pull it away, and look at that. Super close to touching each side once. Remember, I couldn't get it quite perfect the first time off of the computer screen here. Okay, so that's called an in-center because the circle can be drawn inside the circle and touching each side once. Okay, and so the in-center is equidistant because they're all radii, equidistant to each side of the triangle. All right, next, the centroid. The centroid balances the triangle. So it's like if I put a spinner, a little dot or a pin on the bottom of the triangle, I could spin it. This goes right in the middle. That's going to balance it perfectly. That comes from the three medians. A median, as you see right here, is defined as a segment that goes from the vertex to the midpoint of the opposite side. Okay. Now, I would sit there and take a ruler and sit there and measure. These rulers are often, I'm not sure if I'm going to be able to do it or not. I'm not going to spend the time because I can't remember how to quickly rotate these and all this. So I'm not going to use a ruler, but this is what you'd be using a ruler. I'm not letting you having to construct it. I'm just letting you use the ruler, measure it, and find the midpoint. So if, let's say this was 6 inches, I go right in the middle at 3 inches. It should look, and what you could do if you want to practice is you go ahead and put a little dot on the outside where you think the middle is. Then you measure that whole distance, divide by 2, and actually find out where it is and see how close you were to the middle. That gives you a good idea on how good your vision is as far as perceiving things. So here, I'm going to say the middle is about right there. Okay, and on this one, I'm going to say the middle is about right there. Okay, and you, like I said, you would take the ruler and actually measure it. Constructing wise, we would do perpendicular bisectors of the sides because a perpendicular bisector of each side will give me the midpoint. When it goes through and touches that side, it's the midpoint. But to save time, to get through all these, I'm letting you use a ruler, measure it, find the midpoint, and then take your straight edge or your ruler and connect the segment, the vertice or vertex to the midpoint of the opposite side. So vertice to midpoint of the opposite side. Vertex to midpoint of the opposite side. Okay, and notice I did a pretty doggone good job. It looks like it intersects all three right there. So I was barely off. Okay, so that's called the median. Okay. Now, just some special characteristics of the median. The median, you cannot extend these sides out. I saw some people trying to do it with their ruler. No, that's not a median. It starts right at the vertex. You have to stop it at the midpoint and start it at the vertex. You cannot extend on in either direction. The longer piece of the median is 2 times the smaller piece. So the ratio is 2 to 1, longer piece to short piece. So it's a total of 3 pieces, or you can think of it's being divided into 3 parts, not 3 pieces. There's only 2 parts, but 2 pieces, but a total of 3 parts. The longer piece is 2 parts of the whole length. The shorter piece is 1 part of the whole length. So it's a 2 to 1 ratio each time, longer to shorter. If I was to compare the longer to the median, the longer is still 2 parts. The median is a total of 3 parts. So it'd be a total of 2 to 3. If I went the shorter to the median, the whole length, remember the shorter is only 1 part, the median 3 parts. So it'd be a 1 to 3 ratio. So that's true for all of the medians. So if I did it here, this would be the 2x, that's the longer piece, and that'd be the 1x. Or we can say y if you want to change it to a different variable. And then if I did z here, then this is 2z, that's the longer piece. So 2 times. So it's always 2-to-1 ratio for longer to shorter, or if I'm going longer to the entire median, it's 2 to 3. If I'm going shorter to the entire median, it's 1 to 3. You will have a problem dealing with that on the DCAS itself, just so you know that. All right, last one is the orthocenter. This is the hardest one of them. Oops, let's get rid of those. Okay. So what this is 3 altitudes. Okay, and altitude, another name for altitude is height. You need to know that. Altitude equals height. Okay, and again, I'm only doing it on one triangle. On your paper, you might have to do it with a total of 4 triangles. I'm just doing the different types of right triangle, equilateral, acute, and obtuse. So here I'm just doing with example of an obtuse triangle. So an altitude goes from the vertex to the perpendicular of the opposite side. Okay, so altitude goes from vertex to perpendicular of opposite side. Okay, so we take our compass, put the pointer, we'll go start here. I'm going to move it so the pointer is on the vertex. I open it up just past the length of, or just past the opposite side itself. Okay. Then go ahead and draw a, I'll make it a little bit further out so it's easier to see. Okay. Let's go ahead and move it a little further just so it's easier to tell for you guys. Okay, so now I'm going to make a semicircle. So I find 2 points that cross that line. Now from there, I'm going to go ahead and do like a perpendicular bisector between those 2 points. So I open up more than halfway, which it is. Now I don't have to do the full semicircle because I'm going to be using that vertex right there on this side. So I already have the point of intersection there. So I just need to do my arc down on the bottom side. So I can just draw a semicircle, a little piece arc there. Okay, turn it around, put it on the other intersection point right there. Okay, and then draw my arc right there. Okay, so now I take my ruler or protractor or straight edge and connect it right there. And then I should be able to easily tell that that's 90 degrees. It should look like 90 degrees, just like that it does when you're done. Okay, now this one you might need to extend up this way because it could intersect with the other two outside the triangle like it will in this one. Okay, so I did it from that vertex. Now, let's say I'm going to now go to this vertex over here. Okay, well now, if I look at this, in order to get a 90 degrees to that side, I have to extend that side. So I'm just going to change the color so you see the extension. Oops, let's get rid of that. Okay. Oh, I still didn't point. Get rid of that. Okay. So I'm going to need to extend this side out here. I would take my ruler and just extend it out. Okay. So pretend like that was just drawn out there now. Notice I can see that 90 degrees from that point is going to be somewhere in that area. That's why I need to extend it out because that's where it's going to intersect at 90 degrees out there. Okay, because remember the height is always at 90 degrees from the vertex to the opposite side, which could be extending the sides. So it's an obtuse triangle. I'm going to have to extend that side. So again, I go ahead and move my compass just past a segment. In this case, the extended one. My pointer is on the vertex. Draw an arc. Okay, so now I have my 2 points of intersection. Now I can go ahead and find the point of intersection. Okay, so this is a little more complicated now because all right, so let's change the color so you can see it better red. Okay, so I have my little arc there. Okay, I'm going to turn around, put it on the other end where the other point of intersection is, and draw my arc right there. Okay, so now I can take my straight edge and connect it from that vertex through the point of intersection. And I should be able to see that that looks like 90 degrees right there, which it does. Okay, so now if I go ahead and, oops, get rid of that. Notice this, I'm going to have to keep extending further up because it's going to intersect way up here. And this, I extend further up. Okay, take my ruler and extend further up. Okay, and there's that orthocenter. That's where it intersects way up there. So the more obtuse it is, the further away it's going to go. Okay, so that's where the orthocenter is, way outside that right there. Now, if I was to do that with the other one, it should come up there as well. So again, I would have to extend that side, okay, with my ruler. Then again, I would take my compass pointer there, put this just past, right there, just past that, draw myself, oops, didn't draw it. Come on, let's see you draw it now. Why is it not want to draw my semicircle here? It should be on there. Let's see if I change colors, if that'll work. There you go. Just by changing colors, it worked good. Okay, so there are my 2 points. Now I'm going to go ahead and do my perpendicular to that. Okay, move it in. It's got to be more than halfway. Notice I'm not going to be able to get to that because this, I can't adjust my compass. It's going to take me beyond that right there. Okay, so I'm going to just have to do a quick estimate. Okay, I'm just going to estimate it right in there, or if I drew my 2 arcs like this, it would come like this. Okay, because I can't rotate my compass because it's off the page up there. Okay, and then I would take that and extend it. And if I had done it right, so I was just a little bit off. It should have gone intersection right there then. Okay, so I was just a little bit off. And then they would all 3 intersect up there. And you can see that looks like 90 degrees right there. Okay, so the orthocenter takes the most work like that, and you're going to have some that are going to be outside the triangle, some will be on the triangle, some will be in the triangle. If it's an obtuse triangle like we have here, the orthocenter will be outside the triangle. All right, so there you have all 4 points of concurrencies created for you, and that's what you're going to do on that worksheet.